So from the previous example, actually instead of we calculate the interest, each quarter, and then we can use compound interest formula to find the balance, account balance. Okay, so the formula is given by A represent account balance, okay, which is the total money in the account after a certain period of time. Okay, P still represent the principal. Okay, R is still annual interest rate, which is a percent number. N represent the number of time or the frequency of compounding. Okay, interest is compounding how many times. So that's instead of, let's say it's the frequency of interest compounding. Okay, or in other words, number of times the interest compounded. Okay, so in the previous formula, actually we can calculate account balance. Okay, we just try to verify, okay, if we got result correct, from the previous example. That's P, that's 1,000, right, in the previous example, times 1 plus R is 2%, 0.02, and the interest compounded quarterly, okay, times N times T, N equals 4, right, times T is 1 year. Okay, so in the previous one, let me just write it out for you in detail. Principal is 1,000, R interest rate 0.02, 2%, and N equals 4 because the interest compounded quarterly. Okay, 1 year have a 4 quarter. T equals 1 year. Okay, T equals 1 in a unit of year. So that's why we plug in this formula, and then if you put in the calculator, we got 1020.15. Okay, a little bit different than earlier. We got 1020.16 because when we do step by step, we rounded the interest made, right? So that will lose a little bit, precision. So that's why we have 1 cent different. But basically they're the same. Okay, so now we got a compound interest formula, which is calculate account balance. So now if we look at a compound interest formula, okay, which is A equals P times 1 plus R over N raised to N's power, right? So if we just look at this part, okay, 1 plus R over N and then parentheses raised to N power, we only look at this part of the formula. Okay, and then we know this as R, which is interest rate increase, okay, until 1, and then the N, which is number of compounding the interest, right? The frequency of interest compounding increase to the real large number, and then e to the r's power is very, very close to the natural e. All right, so that's why actually we derive another formula. So when the interest compounding continuously, okay, and then we can update account balance by P times E to the RT power, right? So if you look at this, it's R times T power, which one? Oh, N times T power. Okay, so this part, the one I put in the parentheses, actually is E to the R power. Okay, that's why if the interest compounding continuously, we got a formula A equals P natural E raised to the RT power, okay, which is the next slides. A is still account balance. P is the principal, okay. E is the natural E. R is the rate, interest rate, and T is the time. All right, so now let's look at the example. The amount A that results from investing a principal of $1,000 and an annual rate of 10% compounded continuously for a time t of 1 year. So in this case, P equals 1,000, R equals 10%, which is 0.1, and then T equals 1, right? 1 year. And then we can plug in A equals P e to the RT power, right? And then plug in those numbers. That's why we got 1,000 times e raised to the 0.1 times 1 power, which is still 0.1, right? That's 1,000 times e to the 0.1 power. And that's how we got this answer. That's $1,105.17. So this is the formula to calculate if the interest compounding continuously.